Okay, we're going to have a quick recap on medians, altitudes and perpendicular bisectors. Now each of these is a straight line, so you need a point that lies in the line, you need the gradient of the line, and then you sub it into y minus b equals m bracket x minus a to find the equation. Okay, so let's first of all focus on a median. Okay, so if you've got a triangle, call it ABC, each triangle will have 3 medians, all right? So let's say we've got a median from A. What the median does is it comes from a corner, comes from a vertex, it comes from A, and it cuts the opposite line in the middle. Okay, so now you need to find the equation of this straight line. So how would you do it? Well, we need point gradient. Well, where are you going to get your point from? Well, it comes from there, so you can use that as the point. Where are you going to get the gradient? Well, it cuts here in the middle, which will give you a second point. So now you've got 2 points, and you can do y2 minus y1 over x2 minus x1 to find the gradient. You can then choose a point. You can choose this one or this one, both from the line, and put it in y minus b equals m bracket x minus a. Now there's 3 medians in any triangle. There's a median from C and there'll be a median from B. Let's concentrate on this one from A. So let's say that this is the point 5, 7. That's the point 9, 11. And this is the point 11, 9. Okay, so let's say that this median is called AT, so that would be the point T then. Okay, so first move, I'm going to find the midpoint. Okay, so that's going to be the midpoint. Make sure you identify which line you're looking at. You're looking at this line, it's the midpoint of BC. So it's going to be x1 plus x2 over 2 and y1 plus y2 over 2. So that's going to be 9 plus 11 over 2 and 11 plus 9 over 2. And I would head that up first of all with the actual formula to familiarise yourself with that. x1 plus x2 over 2, y1 plus y2 over 2. Okay, so 9 plus 11 over 2, that's 20 over 2, that's 10. 11 plus 9 over 2, that's 20 over 2, that's 10 again, so that's the point 10, 10. Okay, let's put that in, feed that into your diagram. I can now do y2 minus y1 over x2 minus x1 to find the gradient. Okay, so that's going to be 10 minus 7 over 10 minus 5, which is 3 over 5. So the gradient of that line then is 3 over 5. So I've got the gradient. I now need to choose a point, so I can choose this one or this one, doesn't matter, you'll get the same answer. So I'm going to choose this point, I'm going to call it AB. And into y minus b equals m bracket x minus a. So that's going to be y minus 7 equals the gradient 3/5 bracket x minus a, which is 5. Okay, I then look to eliminate the fraction, so I get rid of that divide by 5 by multiplying both sides by 5, so it's going to be 5y minus 35. The divide by 5 and times by 5 cancel out, leave me with 3 bracket x minus 5. 5y minus 35 is equal to 3x minus 15. And that's 5y is equal to 3x, bring the minus 35 across, make it plus. And that will give me a final answer of 5y equals 3x plus 20. Okay, let's now have a look at altitudes. Okay, so again, if we've got a triangle, let's call it this time PQR. Each triangle will have 3 altitudes. So what does that altitude do? Well, an altitude comes from a vertex. So let's say I'm looking for the altitude, which I'm going to call PT. Well, it would come from P then. Now, it doesn't cut in the middle. That's not the definition of an altitude. The altitude comes from a vertex and it cuts the opposite line at a right angle. Okay, so that's going to involve m1, m2 equals minus 1, but it's not going to involve the midpoint formula. So let's put in some points for this one. Let's say that's the point 3, 5. Let's say that is the point 6, 10, and then finally the point 8, 6. Okay, so it's a straight line, so what do I need? Point gradient and into y minus b equals m bracket x minus a. I've got my point, so let's label that just now AB. Okay, I now need to find the gradient. Okay, so how am I going to get the gradient? Well, if you think about it, this line interacts with this line at a right angle. So what I can do then, there's a relationship between this line and this line, which is that they are perpendicular lines. So I need to find the gradient of this line, and then whatever I get, I need to flip and invert m1, m2 equals minus 1, and that will give me the gradient of this line. So first of all, let's go after MQR. That's going to be y2 minus y1 over x2 minus x1. Okay, so that's going to be 6 minus 10 over 8 minus 6. 6 minus 10 is minus 4. 8 minus 6 is 2. Don't leave it as a fraction, simplify it right down. Minus 4 divided by 2 is minus 2. Okay, now before you start plugging that into anything, just be careful. You've only found the gradient of this line. We need to find the gradient of this line, which means we need to set up that m1, m2 equals minus 1. You must write this down. m1, m2 equals minus 1. That's your flip and invert. Now we know that minus 2 could be written as minus 2 over 1. Okay. So you flip that over, change its sign, that is positive 1/2. I've now got my point, and I've got the gradient, and it's into y minus b equals m bracket x minus a. So that's y minus 5 is equal to 1/2 bracket x minus 3. I'm going to eliminate this divide by 2, this fraction, by multiplying both sides of the equation by 2. Y becomes 2y. Minus 5 becomes minus 10, and divide by and times 2 cancels out to leave me with 1 bracket x minus 3. 2y minus 10 equals x minus 3. Bring that across, change its sign. 2y is equal to my x minus 3 plus 10. And final answer is 2y equals x plus 7. Okay, third one, perpendicular bisectors. Let's see that this is STU. Okay, each triangle again has 3 perpendicular bisectors. Now, if I want to find the perpendicular bisector that cuts TU, this line here, what you really need to be careful with here is a perpendicular bisector does not come from a vertex. That's not one of the rules. Now, if it does so in only a minority of cases, and you never rely on it. So we never go to, if I want to find the perpendicular bisector that cuts TU, I can't say that it goes through the point S. If I want to find the perpendicular bisector of SU, similarly, I can't say that it comes from the point T. I can't rely on that. And same here with U. So we're going to find the perpendicular bisector of TU. So let's put in some points. Let's say that that's 5, 6. Let's say that that is the point 9, 12. And then that's the point 13, 8. Okay, so I'm looking for the perpendicular bisector of TU. So that's 13, 8 and 9, 12. So let's draw that in. Okay, so let's draw that in. It's perpendicular bisector, so it cuts in a right angle, but it also cuts in the middle. So that's the perpendicular bit, and there's the bisect bit, it cuts in the middle. Okay, so what do I need? It's a straight line, I need point and gradient. So first of all, I'm going to go after the point. That will be the midpoint. So that is the midpoint of TU, x1 plus x2 over 2, y1 plus y2 over 2. Okay, so that is going to be 9 plus 13 over 2, 12 plus 8 over 2. Okay, 9 plus 13 is 22, 22 over 2 is 11, 12 plus 8 is 20, 20 over 2 is 10. Now once I've got that, feed it into the diagram, that's going to help us. and that's our point, 11, 10. Okay, now how do we find the gradient? Well, it's a perpendicular bisector. So find the gradient here, and then to find the gradient of the green line, I need to flip and invert m1, m2 equals -1. So let's go after the gradient here first of all. So that's going to be y2 minus y1 over x2 minus x1. Okay, so that's 8 minus 12 over 13 minus 9. 8 minus 12 is -4, 13 minus 9 is 4. Simplify that right down, -4 over 4 is -1. And then it's m1, m2 equals -1. Okay, so I need to flip and invert, so -1 can be written as -1 over 1. Flip it over, change its sign as 1 over 1, but 1 over 1 is just 1. So the gradient of the line is 1. There's the point AB, that's the point that lies in the line, straight into y minus b equals m bracket x minus a. And that's y minus 10 equals 1 bracket x minus 11. Y minus 10 equals x minus 11. Bring that over, change its sign, y equals x minus 11 plus 10. And final answer then, y equals x minus 1.